What is convolutional neural network? CNN. Convolutional neural network is a type of an artificial neural network and is made up of neurons that help in image recognition and image processing. It uses deep learning algorithm that takes an input image, processes it by assigning learnable weights and biases to various aspects or objects in the image, which will help the system to differentiate one image from the other with maximum accuracy. We can say that convolutional neural network reduces size, improves features, and gives the probability value of the input image. They are trained to identify and extract the best features from the images. Dog, bird, cat. Pixels of image fed as input. Input image, blue jay. Input layer, hidden layer, output layer. Images processed using convolutional neural network. Output probability, beagle 10%, blue jay 70%, Maine Coon 20%. Layers of convolutional neural network. Convolutional neural network is made up of multiple layers of artificial neurons. It uses mathematical functions to calculate the weighted sum of multiple inputs and generate the desired outputs. Let us discuss in detail about the different layers present in convolutional neural network. Convolution layer. Convolution is the first layer of a CNN and is also known as feature extractor layer. The main purpose of this layer is to extract the high-level features from the input image to perform operations such as edge detection, blur and sharpen by applying filters. Depending on the type of AI model, a convolution layer may be made up of 2 or more layers. In that case, the first convolution layer is responsible for capturing the low-level features such as edges, color, gradient orientation, etc. With added layers, the architecture adapts to the high-level features and a whole network of understanding of images in the dataset. This layers deals with the convolution process of handling an image with several types of kernels to provide different features to the whole system. Each convolutional kernel is used to generate a feature map based on input provided. Feature map is also known as the activation map. Feature maps have multiple uses like the output of the filter applied to the previous layer is trapped by the feature map. It helps in reducing the size of the image so that it can be processed easily. It helps in focusing on the important features of the images like eyes, nose, etc. so that it can be processed efficiently. Rectified linear unit, ReLU. This layer is the next after the convolutional layer. It takes the features map of the convolutional layer and generates the activation map by discarding all the negative numbers of the feature maps. It means all positive numbers will go as it to the system, but all negative numbers will go as 0, which makes the feature map appear as non-linear graph with all positive values. This enhances the activation layer and provides better features to the input image for further processing by the next layer in the CNN. Pooling layer. This layer reduces the dimensions of the input image while still retaining the important features. This will help in making the input image more resistant to small transformations, distortions, and translations. All this is done to reduce the number of parameters and computation in the network, thus making it more manageable and improving the efficiency of the whole system. For example, if an image of an animal is given as an input to the CNN, then by just retaining the shape of the eyes, ears, and face, it is easy to identify an animal. Keeping all the features will just increase the processing time of the image and the complexity of the code for calculating the maximum probability. There are 2 types of pooling. Max pooling. Max pooling is the most commonly used method that selects the maximum value of the current image view and helps preserve the maximum detected features. Average pooling. Average pooling finds out the average value of the current image view and thus downsamples the feature map. Fully connected layer. This is the last and the final layer of the convolutional neural network. After the features of the input images are extracted by the convolution layers and downsampled by the pooling layers, their output is a three-dimensional matrix which is flattened into a vector of values. These values of the single vector represent a specific feature of a specific label and are redirected to fully connected layers to predict the final outputs of the network. This helps in classifying an image into a specific label based on the probability of the input being in a specific class. For example, the input image with a beak belongs to the category of a bird. Convolution plus non-linearity. Max pooling. Convolution plus pooling layers. Vector, fully connected layers. Bird, sunset, dog, cat. NX binary classification. Image classification using CNN. Testing CNN. Go to the link to see how a number written by you is identified based on the classification done by convolutional neural network. This will help you analyze how different layers actually work in coordination efficiency, and it is practically implemented in the real world.